Where does this equation come from? Why is it that a wave's speed is equal to its wavelength multiplied by its frequency? Speed is a way of describing how quickly an object's position is changing, and it's expressed as a change in distance over time, and calculated with the equation speed equals distance over time. So when we calculate how fast something is travelling, we need two pieces of information: how far it moved and how long it took to move. For example, a car that travelled 50 kilometers in 1 hour would have an average speed of 50 kilometers per hour, and a car that travelled 50 kilometers in 2 hours would have an average speed of 25 kilometers per hour. Now, a wave is just a disturbance that's moving through something, so we can calculate its speed the same as any object. If we know how far it's travelled and how long it took, we can calculate its speed. We'll demonstrate this by working out how long it takes a wave to move through the string in the PhET simulation. We'll work out how long it takes the wave to travel a certain distance, so let's say 5 centimeters. Now the simulation is set to slow motion to make this a little bit easier to stop. And so we've got 0.8 seconds. So the wave traveled 5 centimeters in 0.8 seconds. Now using the equation for speed equals distance over time. If we do 5 centimeters divided by 0.8 seconds, that gives us a speed of 6.3 centimeters per second. So that's one way to calculate the speed of a wave. But where does the equation speed equals wavelength times frequency come from? Let's quickly clarify some of these terms. So wavelength, which is represented by the symbol lambda, is the horizontal distance between 2 points of a wave that are in phase. Frequency, with the symbol f, is the number of oscillations per second, or the number of waves that pass per second. Period, with the symbol t, is the time each oscillation takes, or how long it takes each wave to pass. And speed, with the symbol v, is how quickly a wave travels through the medium or through space. So frequency is like saying how many waves there are per second, and period is like saying how many seconds it takes per wave. So these two terms are what we'd say inversely proportional. They're both functions of time and the number of waves, but in opposite ways. So those terms could be expressed in this way. Frequency is equal to 1 over the period, and period can be expressed as 1 over the frequency. Let's check that on the simulation. So with a frequency of 2 Hz, it takes 0.5 seconds for one complete wave to pass. So the period is half a second. So 1 over the frequency is equal to 1 over 2, which is the same as the period, and 1 divided by 0.5 is equal to 2, which is the frequency. Okay, let's put all this together to see if we can get this equation speed equals wavelength times frequency. So we have our speed equation, which is speed equals distance over time. And we know that wavelength is the distance a wave travels during one oscillation. And we know that the wave period is the time taken for one oscillation. So we can substitute into the speed equation wavelength and period and get speed is equal to wavelength divided by period. Now if we get a little bit mathsy, we can rewrite that to be speed equals wavelength times 1 over period. Dividing by period is the same as multiplying by 1 over period. And we've also just seen that frequency is equal to 1 over period. So in the equation speed equals wavelength times 1 over period, we can replace 1 over period by frequency. And that gives us the wave speed equation. Speed equals wavelength times frequency, or abbreviated to v equals lambda times f. Okay, last thing we'll do is just check that that equation gives us the same result that we got when we calculated the speed of this wave earlier. Using the equation speed equals distance over time, we calculated the speed of this wave as 6.3 centimeters per second. But now if we measure its wavelength, which is 4.2 centimeters, and we have its frequency of 1.5 hertz, we can put those values into the wave speed equation. So wave speed is equal to 4.2 centimeters times 1.5 hertz, and that gives us the same answer, 6.3 centimeters per second.